Assalamualaikum dan selamat sejahtera. Today my group will present the project Electro-Pneumatic Technology Laboratory titled BDP Coordinate Motion Control for Sequence Electro-Pneumatic System. Instruction name Cik Sumayah binti Mahsuri and Encik Ahyat bin Muhammad Zaini. So in the table of content we have group member, objective of BDP, design statement, table pneumatic and electric component, displacement step diagram, simulation circuit, discussion and conclusion. So for group member, we have three group member. First, Muhammad Shamir bin Shaharon, DN230091, and me, Muhammad Haris Hamka bin Bakhtiar, CN230074, and last, Muhammad Irfan bin Samsudin, DN230140.
This is an objective of BDP or broadly defined problem. So the first is to develop the Cartesian pick and place robot with an electro-pneumatic control circuit in a fleet sim software. Second, to design, simulate and troubleshoot of electro-pneumatic control circuit using indirect actuation method. And the third one is to demonstrate and troubleshoot the error of an electro-pneumatic control circuit by using fleet sim software. Design statement. The two-axis Cartesian robot as shown in this figure is used to pick the load from box A and place it in box C. Okay? When the start push button switch SF1 and SF2 is pressed, the program trigger the arm to move downward. Hence, it will active the down sensor and also will grip the load for 3 seconds. And after that, the arm move upward and will active the up sensor. And then the arm will move to the right and active the right sensor. And then after it reach, the arm will move down and also ungrip the load for 3 seconds. After ungrip, it will move up and return to its initial position after 5 seconds. And then the system will repeat the process for 7 times before it stop. And by pressing push button SF3, it will reset the process, and this installation will proceed in a continuous cycle. Table pneumatic and electrical component. So this is the list of the pneumatic component that used in our project. First is double active cylinder. Second, 5 two-way double solenoid valve. And the third one is 5 three-way solenoid valve. Alright, and then this is for the electrical components. Firstly is the momentary push button normally open. And then the second one is relay. The third one is solenoid coil. And then the next is the timer on relay and also a counter. And the last one is the magneto proximity sensor.
Coordinate motion control using displacement step diagram. The displacement step diagram outlines the sequence of actuator movement in the electro-pneumatic system for the one complete cycle. The new diagram categorizes action into three motion types: 1. Left and right, 2. Up and down, and 3. Grip and ungrip, ensuring a clear understanding of each actuator role. Key component: actuator grouping, step S1 to S30, timing and delay, and sensor. Step-by-step sequence. Initial position S1. The system starts in the initial position with BG1, BG2, BG3, BG4, BG5, and BG6 in their natural state. After we push SF1, negative SF1 and negative SF2, motor will move downward S2 to S3. BG4 extend, the arm move downward. Down sensor active, confirm the arm and position before processing. Next, grip the load S4. PG6 extend the gripper close to the grip load, and T1 3 seconds allow time for a sequel grip. Next, move upward S5 to S6. PG3 retract the arm, move upward. Up sensor active, confirm the arm position. Next, move to the right S7. BG2 extend, the arm move horizontally to the right and right sensor active, confirm the position. And next, move downward and release load S8 to S9. BG4 extend, the arm move downward. BG5 extend, the gripper open the release the rope to release the load. T2 3-second time for the gripper to ungrip the load. And then return to initial position S10 to S30. BG3 retract the arm, move upward. BG BG1 retract the arm, move back to the left. T3 5-second delay before the next cycle begins. Cycle The next cycle repeats 7 times. The sequence is repeated for a total 7 cycles, ensuring process continuity. For the reset, the after the cycle repeats 7 times. For the reset, we use switch SF3 for the reset and continue. That's all for displacement step diagram. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Irfan bin Samsudin, metric number TN230140. So today I want to present about our simulation project. In our simulation, we use 5 3-way double solenoid valve for negative mm1 double acting cylinder, and 5 2-way double solenoid for negative mm2 and negative mm3 double acting cylinder. And for the negative mm1, it used for left and right position, and negative mm2 for up and down position, and negative mm3 for grip and ungrip position. When I run a simulation without pressing any push button, negative SF1 and negative SF2, solenoid coil negative MB1, negative MB3 and negative MB5 will de-energize, and due to dominant spring return DCV, right switching position is activated. Compressed air will flow to port 1, will shut off, and air will not allow to flow through and double acting cylinder negative mm1, negative mm2 and negative mm3 in fully retract position. Alright, when I push both push button, which is negative SF1 and negative SF2, the current will through counter contact negative C1, and relay coil negative KF1 will energize. Then relay contact negative KF1 will close to make a latching on in the circuit, and relay counter negative KF1 will close contact and flow a current through relay contact negative KF3, negative KF5, negative KF7 and negative KF8. Add a normal close contact to activate solenoid coil negative MB3. Then activate left switching position and allow it to flow from port 1 to port 4, and the position road negative M2 will fully extend position for double acting cylinder DSC. Then magneto proximity sensor negative BG4 will activate and energize the coil relay negative KF2, that through from relay negative KF7. Then relay contact negative KF2 will close and flow the current through relay contact negative KF5, negative KF7, negative KF6 in normal close contact to activate solenoid coil negative MB5. Then activate left switching position and allow it to flow from port 1 to port 4. The piston rod negative mm3 will fully extend position for double acting cylinder DSC. After piston rod at negative mm3 will fully extend position, magneto proximity sensor negative BG6 will activate and energize the relay negative KF3, that through from relay contact negative KF5, and relay contact negative KF3 will open and turn off the current for solenoid coil negative MB3, which is here, and relay contact negative KF3 will close and flow current through negative KF7 and activate timer for negative T1 for 3 seconds. After the timer negative T1 count for 3 seconds, the timer contact negative T1 will open and flow the current through to activate solenoid coil negative MB4. Then activate right switching position and allow A to flow from port 1 to port 2, and the piston rod at negative MM2 will fully discharge position for double acting cylinder DSC. And the magneto proximity sensor negative BG3 will close contact and current flow through relay contact negative KF3 to energize relay coil negative KF4. And relay contact negative KF4 will close and current flow will activate solenoid coil negative MB1. Then activate left switching position and allow A to flow from port 1 to port 4. Will fully extend position for double acting cylinder DSC. This negative MM1 will fully extend position. Then magneto proximity sensor negative BG2 will close contact and energize relay coil negative KF5. And relay contact negative KF5 will open and deactivate solenoid coil negative MB5 at here, and negative MB4, which is at here. Then relay contact negative KF5 will close and activate negative MB3 at here, and magneto proximity sensor negative BG4 will close and energize a relay coil for negative KF2 at here. Okay. Then relay contact negative KF5 and negative KF2 will close and activate solenoid coil for negative MB6. Then relay contact negative KF2 and negative KF5 will close and activate the solenoid coil for negative MB6. Then activate right switching position and allow air from port 1 to port 2. And piston rod for negative MM3 will fully discharge position for double acting cylinder DSC. Then magneto proximity negative BG5 will close and close contact, and current flow will through relay contact negative KF5 and negative KF7 in close contact to energize coil relay negative KF6. And relay negative KF6 will open and deactivate negative MB5, which is at here. And relay contact negative KF6 will close and make a latching on negative latching on for negative KF6 here. And relay contact negative KF6 will close and activate the timer negative T2 for 3 seconds. After timer negative T2 count for 3 seconds, timer contact negative T2 will close and energize coil relay for negative KF8, and relay contact for negative KF8 will open and deactivate solenoid coil for negative MB3, and relay contact negative KF8 will close and activate the solenoid coil for negative MB4, and then activate right switching position and allow air to flow from port 1 to port 2 at the piston rod negative MM2 will fully discharge position for double acting cylinder DSC. And relay contact negative KF8 will close and activate the timer for negative T3. After timer negative T3 count for 5 seconds, the timer contact negative T3 will close and activate a solenoid coil negative MB2 is here, and then activate the right switching position and allow A to flow from port 1 to port 2 piston rod negative MM1 and wheel of fully discharged position for double acting cylinder DAC, and magneto proximity sensor negative BG1 will close and the current flow will through relay contact negative KF6 and KF8 in close contact to energize coil contact negative KF7, and relay contact negative KF7 will open and deactivate solenoid coil negative MB3 and de-energize coil relay negative KF6 negative KF2 and timer T1, and relay contact negative KF7 will close and activate a counter negative C1 for 7 times, and push button negative SF3 as a reset button at the counter C1, and this simulation will continuously cycle for 7 times. And as I tell before, negative C1 will close contact after the negative C1 timer count for 7 cycles or 7 times, and for the push button negative SF3 is as a reset button, so the simulation can operate again if we push negative SF1 and negative SF2 both. So I will continue for discussion part. From the simulation project, I had to first, the challenging that I get is a make a latching on and detect off contact to activate the solenoid coil negative MB3 and another solenoid coil 2. And next, number 2 is to make cut off the current for certain solenoid coil and coil relay. And lastly, make a counter negative C1 for continuous cycle for several times in circuit. Thank you.
Okay, so for the last is a conclusion. This project focused on coordinate motion control for a sequence electro-pneumatic system involving the design and simulation of a two-axis pick-and-place robot using FluidSim pneumatic software. We gain hands-on experience with pneumatic component, sensor, and control circuit, comprising accurate timing, proper sensor placement, and troubleshooting for seamless operation. Next, key challenge, including programming error and synchronization issue, provide variable problem-solving lesson. The project enhances our understanding of electropneumatic system and improve teamwork and technical skill, preparing us for real-world automation tasks. Thank you.